Hi guys, it's Mrs. Moss here. We're going to continue our star discussion and really look at what a star is. Check out this picture though. Do you remember what this is called when it's a collection of gases and atmosphere kind of coming together and swirling? It's a nebula. This is the beginning of a star. So what is a star? Well, it's a large sphere of gas. It produces its own energy, which means it produces light and heat energy. And all of that is held together by gravity. Our solar system has only one star. That's it, the sun. So let's look at how energy is made from a star. Because as we know, we get a lot of energy from the sun. In fact, all of our energy comes from the sun. So how is that possible? Well, it's possible because of a process called nuclear fusion. Nuclear fusion is the combination of two smaller atoms to form one larger atom. And in this instance, we are taking two hydrogen atoms and fusing it into helium or burning it into helium. And with that process, energy is released. And as you know, this does produce huge amounts of energy. Now, nuclear fusion can only occur in extremely high temperatures and high pressure conditions that really only exist in the interior of stars. Okay, so if you look at this diagram, it's showing you two smaller atoms. In our instance with nuclear fusion, these are the hydrogen atoms, and as they combine to form one larger atom called helium, it releases energy, and that's what we feel here on Earth. So let's look at how stars are classified. Well, we have a chart in our reference table. It's on page 15. And if you look at it, it goes based on the temperature and the luminosity of stars. Now, when we talk about luminosity, we're talking about the star's brightness. Luminosity is compared to the sun's brightness. So if a star has a luminosity of 100, then that means it's 100 times brighter than our sun. We label our sun with a brightness of 1. Here's a picture from the reference table that I was talking about. Let's look at it a little more closely in this instance. Now, can you find our sun? Here it is. And if you look, you'll see on this chart are all of the classifications or the types of stars. You see we have the main sequence, supergiants, giants, we have, again, main sequence, white dwarfs. Now, what you should be noticing as well is the luminosity. And you'll see that it's decreasing from top to bottom. Okay, and that's kind of typical. This is a base 10 unit, so everything within here is going to be 100,000. Everything in here is the 10,000s, 1,000, 100, tens, and ones, and then conversely going smaller than 1. And if you notice where our sun is, it's directly at 1. So everything above our sun is considered brighter or has a larger luminosity. Everything below our sun has less luminosity, so it is less bright. Now I want you to look at something else. I want you to look at the temperature. And what you'll notice is this is different from our standard graphs. The 30,000 degrees Kelvin, Kelvin is the unit that we measure degrees of temperature on the sun, and this is on the left side. So as we go across the right of this chart at the bottom, okay, let's get my mouse going in the right direction here. We start at 30,000, and as we go to the right, it gets less hot. So it gets colder as we go to the right. This is very different from what we normally see on graphs. I need you to draw your attention to that. And if you need to write hot on the side where the 30,000 mark is, please do. So when we look down from these stars, we look down and see the temperature. So here's the colder spot. The smaller stars are on the bottom right corner of the chart, whereas the larger, brighter stars are going to be up towards the top, and the hotter stars will be in the top left corner. Spica is considered the hotter, brighter star. So again, this is the characteristics of star chart on page 15, and you need to take note of some of these general trends when we read this chart. So what we said before, as temperature increases, luminosity also increases. Hot, bright stars are located in the upper left corner, and cooler, dimmer stars are located in the lower right corner. And the color of the star is dependent on its temperature. Similar to a flame, red is cool, but blue is hot. And here's a picture of the sun. We're going to take a closer look at our sun now and learn a little more about besides just how it creates energy. As we may have seen from our chart, it is a main sequence star. It's a medium-sized star. We said before it produces energy by nuclear fusion. The hydrogen atoms are being fused into helium atoms, producing that energy. And as we all know, it is the center of our solar system. Okay, here's a picture of the sun. Now, this is an interesting chart. It compares the sun with some of the larger stars around it, some of the stars that we see on the reference table chart, and a couple of others just for comparison. Now, if you look in the center of the screen, we have the sun here, medium-sized average star. If you look at Aldebaran, which is a little larger than us, and Arcturus is a little bit smaller, like in between our star and Aldebaran. But then you got to look at these red giants over here. Here's Mira. And if you look at comparison to the size of our sun with Betelgeuse, this is a red giant, a supergiant, and Musafai, I guess, excuse me, I don't know how to pronounce that one. But these are red giants, and you can see the supergiants, how large they are in comparison to our sun. And our sun is so much larger than Earth. So this gives you a good perspective of just how incredibly large these celestial objects are. And that is the end of stars. Okay, we're going to talk a lot more about it in class, and we're going to learn more about some other celestial objects as we move forward in our unit. I hope you have a great day, and I'll see you next time.